Hey guys, this is Brad with Blue Nile Farms. Today I want to talk about the alternate plastic welder and the June Jip plastic welder, how both of these two can really do a lot of reconstruction on a hay hut, for example. They had a lot of breaks and over 15 foot of welds they had to be done. So I'm going to show you some techniques, some tricks and tips to really put some strong welds down, that if you learn these tips, you can fix anything from a real tiny crack to a very large crack just with these two tools. And they retail for under $100 together. So with that said, stay tuned and I think you'll enjoy the video. So to go around and show you the damage of what these horses have done to this hay hut, you can see that there's cracks right along the feeder part on both of these sides here. And basically if we go around here, you'll see a lot more cracks. So this is one of the easy repairs that I know that we're going to be dealing with. And there's pretty much 8 holes in this feeder, and pretty much most of them, if not all of them, have holes. Now here's a part that got damaged, and I don't have this extra piece, but we're going to try to clean it up a little bit. We're definitely going to weld this back into play. And I may have a hay hut that I may take apart, or somehow make a piece that will fit this hole here to kind of build it back. But I will have one feeder that I may just tear apart and use it for parts. Now as we travel around here is where our biggest damage has been. This panel that's on the ground completely got ripped off, and we're going to try to weld that back. And you can see that there's a weld up here on the seam. So we're going to try to weld and fix all these pieces with this welder. And on this one side, it's basically the only side that has 0 damage. So that's a good thing. But this is going to be a good test for this welder, and there's going to be a lot of welding to be done on this. So hopefully you guys can see how well it works. So this is the all-turn kit. Basically it comes with the gun, some snips, a knife, basically different style wires that are used to connect corners and straight pieces. This is the one that I'm most interested in here, and I actually bought extras of these because I know I'm going to use them a lot. And these are the ones that they use. They call them wave staples, and these are the ones I'm going to use basically to fix almost all my broken pieces. And the wave staples are basically what's going to be our binding. And then there's also plastic strips in here of different colors, but if you use the right type of plastic, it really doesn't matter. And all I'm going to use that for is filler. So this is the kit itself, and supposedly it works out real well, and I'm looking forward to trying it. So this is what we're going to do. This is the unit. I bought this off of Amazon. I think it was only like $40. It wasn't that expensive. And it came with some pretty good reviews, and so I'm hoping that it works well. And the thickness of plastic that we're going to be welding today is about 1/8 inch to a little bit less. And so that's kind of, I think, a good test for this. And I have a lot of other little plastic pieces that have been broken, but this by far is my biggest plastic piece with the most damage. Also in the kit, they have these 2 smoothing attachments to basically break down and smooth out plastic filler pieces, and they came also with the kit as well. So overall, this kit can do a lot of different things, and I'm pretty excited about it. So let's see what it can do. So basically, you get this to work, you use this gun, and the gun actually has a light on it. So when you're actually using and applying these clips, you really would like to, are better off with less light, because it's a lot easier to see what you're doing without it well lit. Also, light distorts you to see these things turn cherry red. So once you squeeze the trigger, this wave clip is going to get cherry red. Then you stick it into the plastic and you hold it as long as it takes to get to your proper depth that you feel you need to go. Then I suggest you release the clip, your trigger for a few seconds, then pull away, because if it's still hot, the clip may not release. But if you let it set for a second, it starts to cool off real quick and bonds with the clip. So to heat up this clip, all you have to do is hold the trigger, and I want you to really see how red it gets. And there's the light, but I'll try to cover the light. And if you hold it, it'll start to get really red. See how red this thing's getting? Now that's cherry red. And once it's that hot, then you actually stick it into the plastic and let go of the trigger and let it cool for a few seconds. Then as soon as you pull away, that clip will fall off the end of the electrode and it will be holding. So let me show you real quick what it looks like after I stitch an area. This is an area that I stitched, and it's probably a good almost 9 to 10 inches long. And you can see these wave clips, they go all the way across. And it almost looks like a stitch job. And I'll tell you, once it cools, it's really pretty solid. And I have to break the ends off. I have not done that yet. And I actually put a wave clip also at the end just to make sure that it's sealed. And what I'm eventually going to do at the end is come back and probably melt plastic also on both sides just to smooth everything out and probably give it a little bit more strength. Now I didn't do any cleaning to this either because I don't see no sense in cleaning much when you're just molding plastic. But I think when I do apply plastic in between here, I may clean it and then see how that adheres, because that's where it's going to actually have to get mixed together with the pre-existing plastic. So I'm going to start to actually show you how to put a wave clip in. And I'm going to start here and work my way over. There's a hairline crack up here and a crack here. I'm going to try to seal all of them down all the way to where it's clamped. And we'll start here. So I'm going to take the gun and I'll hold it, and it's going to get cherry red. And this is the one I used before, so it's taking longer than normal. It seems like once they heat up once, they're good, and it takes longer the second time or third time they use them. It's starting to get hot. It's taking a while. And once it's hot, you just basically get it, hold it in place till it embeds to where you want it, and you let go. And as it cools, then you pull it out. And so what you have is two prongs here, and it started to do the weld. So I'm going to continue with these on both sides until this is full. And that will secure this in. Then I'll remove this clamp. I think it's better to work toward the clamp or work at an area of a clamp so you can at least bond with it. But I like to start at the beginning and work my way down to make sure that I have a full weld. It's relatively very, very simple to do. Now, since I'm doing this video, this light actually makes it harder to see this thing heat up. But basically, you hold it till it gets hot. This is the second clip I'm putting in. You can see how cherry red it is now. And then I'm going to try to get in my spot that I want to be. I'm going to hold it till it beds in. And if you hold it too long, you can actually go through some of your thinner plastics. So that's the second weld in. So I'm going to continue on with this wave clip till I get to the edge here. And then I'm going to start the other one and come back through. You know, once you get a rhythm, it actually goes pretty well. And I'm probably using more clips than most people, but because this is a hay hut and you get a lot of horses that really do a lot of damage, you know, and they're really hard in these hay huts, the more you can secure this, the better off you are. So there you have it. So here's 3 wave clips. I've basically filled probably 2 inches with 3 wave clips. So, you know, I bought all these extra wave clips because of the amount of work that I'm doing. But it's amazing how much stronger this thing gets very quickly just by using these types of clips. There's different styles and different, I think some are 6 millimeter and some are 8 millimeter. You know, I don't think it really makes that much difference. I'm just using the wave clips themselves because, like I said, I'm going to try to do a combination of both the wave clips and filler, and I think that'll make everything tight. I'm going to start this one here. It's another spot. It has a crack in it, and I want to seal it. So it's cherry red. I'm going to melt it right in and hold it till it goes in a little bit. And I'll stop, release the trigger, let it cool for a second, pull out. And again, it's holding really well. I'm actually really impressed by this. And it's just time, it takes a little bit of time, but it's really not hard. And as far as the smoke goes, you know, it is a smoky thing, and I wouldn't want to be sucking into fumes. I mean, if you feel like you need a fan or respirator, it's up to you. But it's really not too bad. It is definitely a lot easier to do this when in the dark. And depending on the angle that you're at, it's going to make a difference as well. Here's another one. Just wait till it gets cherry red. That's really the key. And it'll melt. You hold it and just bed it right in there. Now, I haven't pulled any of the clips out yet. I broke them. I mean, you can break them along the way. I'm just leaving everything to the end. Well, I think you understand the concept here. And then I'm going to try to keep this as tight as possible. Then, like I said, if there's a gap or something, I'm going to try to use filler to basically seal the deal in and make it a little bit stronger by adding plastic. Now, I have plastic from another hay hut or a piece that broke off, and I'm going to use it so I know the plastic's going to be exact when I actually melt this together. All right, here's a better close-up. Hopefully you guys get a visual. I'm going to kind of do this upside down. So again, hold it until it turns cherry red. Here we go. Then just kind of like branding. Hold it till you brand it. Let go, pull it out. Do one more and go from there. Tell you though, since I've owned hay huts, I let this go way too long. If I would have done this a long time ago, none of my hay huts would have been this bad a shape. So it was my mistake. Didn't know anything about this stuff that it even existed. But I'll tell you, it's well worth a tool to own because it really makes a heck of a difference in what you're doing. Now right now I'm getting to the seam where they basically lie together. So I'm going to take this S-clip and try to kind of bond between both of those clips. So I think that's going to be more of a critical nature of, you know, getting all these together. So see if I can get this to work. Cherry red, keep it in the middle. There you have it. And I think that locked it in a little bit in the crack where I needed it locked in. So that's where it wide, and I got that filled in now. And to get a really good view of how close this is kind of the fill. You can see how they make little S's in the crack, and it does a really nice job. So all I need now is to continue on with that crack and finish it off. But it's very, very, very simple to do. And I'll tell you, it's amazing how strong it actually holds. So as far as hairline cracks, I have to say that welder did a great job. And I'm really happy with those wave staples. I mean, they wound up really securing this really tight, and I'm really happy with that. Now I'm going to try to line this piece up that's down here that's broken completely off, and it's going to be really hard to line it up really tight. So I'm going to do the best I can. Hopefully I can start securing it with wave staples. The other problem is it's like 30 degrees out. So I'm going to put the bullet heater to this because this thing's been distorted for so long. Hopefully I can get some flexibility back in the plastic and to get a starting point. Then I can kind of clamp it along the way or somehow get it secured where I can start taking those wave staples and forming to this. But to get this in a proper, perfect position, I don't know if I have all the right plastic here. And secondly, I think it's going to be really tough. But, you know, with the simple $40 gun, if I can get this piece on, even if it's done kind of half-assed and it's secured, it does a job, I'll be more than happy with that because I know at least that this thing's going to work. And, you know, if I can get this out in the field and usable, you know, I'm saving myself a $1,000 hay hut and putting it back on the field. So we'll see what happens. So you can see this is a corner that we need to finish. And you can see it toward the bottom how it's sucked in. So by heating that corner with the bullet heater, you know, I think that will actually kind of make the outside pliable, and I can pull it out and make it to match. And then you can see my staples, they were horizontal because it was tight. So when I got in here where it started to gap, I went vertical. And hopefully that'll give me some bind to it, but it's definitely a lot stronger than it was. Now I did this on the outside. Normally I do this the last time on the inside. I might put a few on the inside as well. But I'm, you know, just to get this together is worth its weight in gold. This side here, it's going to be kind of funny because it's the way it's cut on the angle. And I'm going to have to do the same thing and pull it together. You know, what's interesting about these hay huts, they go outside, and if they lay a certain way, they get sucked in. You can see that whole bottom is sucked in. So I'm going to try to heat it up and maybe push it out a little bit. And if I can somehow get a clamp to it, which I don't know if I could, we'll see how this works. If anything, I don't know. We'll see what happens once I get it hot. I think that'll make the difference, and I'll know where I'm at. So let me show you the bullet heater in action and see if we can loosen this up. So the bullet heater is going to be working. It's going to be putting the heat to this corner, and hopefully that corner, you can see how much it's sucked in. We'll heat this up enough that I can kind of toss it out. So we have to get that gap pushed in. So the hotter it gets, the better off we'll be. And the odds are I'm probably going to try to weld it on the outside if possible, but I may have to go on the inside. It's hard to say yet right now. And I'm just happy just to get it to attach. So while that bullet heater is working, you can see it's starting to soften up. So I could actually probably put a staples at least in here or down to here, and I'm just working my way down so I'm able to kind of tighten this up. Then eventually I'll get that hot or the middle hot, try to pull that out and just try to keep working my way down that seam. But right now I'm about as close as I'm going to get. So if I can start putting some staples in here while it's heating up, I'll just turn that off real quick. We're going to make a little bit more headway, and it's going to be more correct. And then we'll just kind of keep pulling it down. Because we are working with plastic, heat's our friend, so I'm just going to keep using heat. So that heat's definitely going to do the difference, and that's what's nice about having the bullet heater, working outside here in the cold, is not only keep me warm a little bit, but definitely kind of knock this out. So what we're going to do is, this thing's really forming itself in. So I'm going to try to get in one of these middle spots, push it, and then put some heat to it, and get a staple in. Kind of work my way back up to the top. Now I'll tell you, it makes a difference. Now you don't want to take too much leeway here as you go, I think. You know, 4 or 5 inches, and I'm just trying to kind of get this as tight as I can. This is actually working out better than I thought, to be honest with you. I had thought when I first had this was such a jagged cut that it was impossible really to hook this thing up. But I think it's working out pretty good if I can keep this in here. You know, I prefer to go on the inside, but you know, it really doesn't matter on looks because this is just a hay hut. But exterior is the only way to do it by yourself, you know, and at least on this little side job here. I might put some staples, like I said, on the inside. I'm not too sure yet. See how it goes once this is all attached, and I just want to make sure it's strong, but I do think these staples seem like it makes a big difference. I can't imagine just putting raw plastic in here. You know, screen probably would work, but there'd be a lot of screen, there'd be a lot of melding. So I'm going to just keep knocking this out, and then we'll work on the bottom. But you see the bottom's a lot closer than it was when we started. And you know, I knew this part was going to be the most challenging part. And I think that now that I'm starting to understand this a little bit better, I think that this will work out really pretty nice. And the outcome is going to be well worth a little bit of this work. So it's definitely looking good. Like here, down here is going to be the biggest challenge, and I'm probably going to have to heat more in the center of this to really loosen it up to actually get to that. And the problem is, unless I flip this over, which I might do on its side, but the problem is it's kind of hard to do with that other side flapping. I don't want to break it off, so I'm going to try to weld it. Everything I do, basically, where it stands on the bottom. So you can see by putting a lot of heat to this thing actually really started to come in tight and started to be get in the right position. So what I'm going to wind up doing is set more of these waves all the way down, probably to about here. Then I'll heat that center up again and try to push out the last bit of it and get as close as I can. Because you know the strength's going to be at the bottom, and worst case scenario, I'll take some filler and some metting and just fill it in if that's what it takes. But I definitely want to get this thing back together. And this is a crucial piece to get on. So once the first one's on, putting the second one on is going to be, you know, a little bit easier, I think. This one was a tough little project for a rookie, and I'm pretty happy with it so far. So with the bullet heater off, I'm going to just start putting welds in. And I'm going to probably get down about here. So the welds start here. I'll get down to here. And then we'll see if I can compress it just a little bit more and see if it works. Plastic's pretty hot. I mean, I could feel this hay hut. It's pretty warm. So it definitely softened it up a bit by putting the heat to it. You know, the problem with these hay huts, when they get in a bad position or they're sitting in the field for a long period of time, you know, if the horses push them in and they stay in that certain position throughout the summer, you know, throughout the heat, they create that form. So they're not as perfect as they are when they come from the factory, but it's definitely a better thing to do. Try to save these huts and buy another one. So this is the weld so far. It's almost done. Started here. We got that whole side done. It went all the way down to the bottom. Got staples all the way down, those little wave staples. And I just have about 6 inches at the bottom here, which I'm going to kind of do last, I think. I'm going to go and attach this side next, and then flip it on its back maybe, or heat it up and do the finishing touches after I get that little corner done, because the only way that's going to tighten up is if I pull that one side out. But this side here I want to get attached and see where we're at then. So this is the last piece, and we'll see what happens. So I want to show you guys is I put a ratchet strap all the way around the hay hut, and I'm going to be pulling this corner together once I start applying heat. I want to show you that as I started rolling this down across the bottom, it's really pulling that one right in perfectly. So I'm going to probably put a weld right here at the bottom. As this tightens up, it's going to get perfectly tight, and this one piece is going to be on really nice. So I'm very happy with that. So the kicker now is to line up this one, and once that's welded into place, you know, this hay hut is darn near done. And I really saved this one. And I think that it's going to be held very well. I think it's very impressively welded together. I put a lot of staples in it. Those wave staples seem like they're embedded in there. It's a lot better than just applying plastic. And like I say, I think this is the way to go. And I would definitely suggest if you have a hay hut and you have cracks and you don't want to go as extreme as I did, you can easily repair your own. And it'll save you a lot of money. I'm kind of excited to show you guys how well this thing worked out. You know, between the bullet heater heating up the frozen pieces and they're a little distorted, it really kind of loosened up the hay hut where I can actually move it around a little bit as a piece. Secondly, you know, that gun putting in these staples really connected this thing well. And I think I did probably a 90+% job as far as matching the pieces. So I'm really, really happy with that. And I'm going to show you how well this worked. I also used a ratchet strap to tighten it up and pull everything in place because, again, I'm a one-man show. And it really pulled this project together well for me. So let me show you exactly this big piece going in. So you can see from a distance, it's all in, and I put the ratchet strap and I kind of worked my way down. And this side here, for the most part, really came in well. And sure, there's a lot of staples. But even going down all the way to the bottom, this thing's pretty tight. And it looks like I have to put a few staples at the bottom, but it really tied in together well. This other side isn't as good, but as good as it's going to get because it was ripped off at a really bad angle. And there is a gap there, and I put the staples in horizontally. There's a hole there where we're going to put a screen and we're going to fill the whole thing in. But all the way down, for the most part, other than at the total base, it's tight. And I can't ask for better than that. So there's more staples I need to put in, and I'm really happy with this. So our project, as far as putting in the staples, that is complete. I just went around and I wound up cutting off all the barbs that are protruding on all the welds that we put in with the staples. And what I have to tell you is the Ultron kit came with this wire cutter. And I really didn't like it that much because it was not spring loaded. So I grabbed one that is spring loaded because they had a lot of staples and it made it a lot easier to cut. Secondly, these little barbs, when you do cut them, they shoot everywhere. So be careful to wear eye protection because it's very simple to get one of these in your eye. And lastly, you don't really cut it down to the base. So you're going to have a little bit of a sharp protrusion at the bottom of these staples. So I'm going to take a die grinder and go over each one of them really quickly, hopefully to take it down a little bit lower. And then I'm going to apply plastic over the top of it and to seal all the cracks. And then we'll smooth that out. And I think that'll do the job. And that's what we're going to do next. So after you take the pliers and you wind up cutting all the little barbs all around after you put all those staples in, the next thing you need to do is grind them out because there's about a 1/16 of an inch of the barb that stands out. And if you touch it, it's really sharp to your finger touch. And since this is for horses, I definitely don't want to see it. Even though I may coat it with plastic, I really don't want to get barbs that protrude. So what I want to do is taking a die grinder with the little stone type tip, and I want to run it across all the barbs. It took it all off really quick, and it was really a good way to go for me. So if you have air, little die grinder, they work out good. If you have electric, like a Milwaukee or DeWalt grinder, use those. They'll work out for you too. The bottom line is get some kind of grinding device to take care of the barbs. This is really fast and efficient, and it didn't cut into the plastic at all. So it was just really fast to cover a large area in a short amount of time, and I really liked it. So I highly endorse some kind of air grinder. And once you get that ground, like I said, now we're going to move into actually applying plastic. So last night I took the Ultron and I wound up putting this little smoothing tip out and held the button and started to smooth and melt plastic up here on the top where we had a big crack, and it did a really good job. The problem though is it seems like this thing overheats and shuts down, and it was getting a little aggravating for me. Also, this tip gets really hot and I think I was putting too much pressure in and it started to bend. So my suggestion is this tool here itself really is not going to really heat up a large area that I'm looking to do because I have so many staples everywhere. For a small project, this thing is perfect for melting a small area, but don't expect to do a whole bunch of melting in a larger area. If that's the case, I think you're going to have to get a better tool, and this is not the one for you. Now, Ultron comes up with one of these heating type knives like this. This one's actually on right now, and this one I wound up buying from Harbor Freight. They were on sale. They're like 14 bucks. And I thought, hey, you can't beat that. So I want to buy 2 of them just to be safe. But this tool here will stay hot and will do a better job, I think, as far as melting the plastic, where the Altern is better for stapling. Now, Altern does sell something similar to this, exactly like this, basically, in their brand. And I suggest if you're going to really melt plastic, I suggest you buy one of these. I think this will do a better job to get a better type of blend and to smooth the plastic in. So my goal right now is to take plastic, clean it, smooth it out, and start to fill in any of the gaps that we have our staples in. And I'm going to use a staple kind of like a backing and to hold the plastic in place. And areas that are too wide that I couldn't get plastic in, I'm going to put a screen in. But right now, I'm just going to smooth in the areas that I have staples in and see how it works. And we're going to use this tool to heat an area and see how it works. But I think this is going to be more efficient, and it's going to stay hotter longer, and it's designed really to stay on. So I think it'll do a better job of melting the plastic. And like I said, for the money, you can't beat this one for $14.99. I was looking online, saw one made by another company, and they wanted $150 for something similar to this. So, you know, for $30 for 2 of these, even if this breaks, I'm not going to argue too bad. Secondly, a lot of people complain that this gets so hot it breaks the tip. You know, this is a hot item, and you're melting plastic. You just need to put it on very gently and let the heat do its job, not you pressing on it. So I think guys are putting too much pressure on the tips, and that's why they broke. And I noticed that yesterday that I was trying to smooth things out, and you get in a habit of, because it wasn't keeping the heat. I think this thing here is going to keep the heat a lot better, and I could see it starting to get hot. So I'm sure that this is going to do a lot better of a job. It's a little flatter and thicker to really absorb and move things around. So let's go see how this all works. And I'm going to take you through the process that I'm doing. So the first thing we're going to do before we do any kind of welding is clean our area, because we don't know what type of contaminants are on here. Now, a lot of times I was looking online, and a lot of people were talking about using isopropyl alcohol or methyl ethyl ketone, which I found that in Ohio is restricted. So I found something that's like methyl ethyl ketone. It's kind of like a substitute, and that's what I'm going to use because it supposedly works really good for plastic type welding. So I'm going to stick with the methyl ethyl ketone type product, and we'll see how that works. So first thing we're going to do is take a rag and clean our areas that we're going to weld. Secondly, I have a piece that was made by Hey Hut, a piece of plastic that I'm cutting off, and I'm going to try to bond that with this plastic because I know that it's probably from the same company. It should be very good for an adhesive, and I think that'll work out good. So let's see how this all works. So I have a rag with methyl ethyl ketone in it. I want to clean the spot where we're going to weld. I'm going to just take this and kind of clean off this outside to make sure that when we put this adhesive down that it's going to adhere. It's not that it's fancy. I want to make sure this is clean so we have a clean surface. And hopefully it'll bond better. And that's why they say to clean it the process. And if I weld on the inside, I'll be doing the same inside and out, just because I think it's going to come through. So I'll do that first, and then I think that you'll be good to start. So this was the top of a Hey Hut. They used to have a cable on top. This got broken. Wound up taking a cutoff wheel. I would cut up a small strip off of this. Then I would clean it with methyl ethyl ketone. And what I wound up getting is this larger, fatter strip. And this is probably pretty thick. But what I was going to do is I was just going to feed it and then use the tool and melt it into the grooves and fill stuff in. So it worked out really good. So let me show you what I've done so far, and then let me show you what an area we're going to do, and I can kind of let you watch and then show you how this works. But bottom line is, all we're going to do is put filler where the gaps are, to especially a thicker gap with something like this, to bond it to our staples. And like I said, use our staples as the strength, and this is just the filler. And I think this is going to give us double protection to get this thing tighter and in better shape. Hopefully it's going to be secure enough that it's going to adhere and it's going to reduce any future cracks. So here's an area that I already did, and you can see how the weld actually filled in. And there's a couple little holes, but I definitely blended in our staples. And over here, you can see where I haven't done it and where the staples are. So using that tool, we're able to blend. So let me show you how we're going to do this. And I'm going to move over to a fresh area on the other side, and I'll show you how we continue our blend. So you can see that we have our staples, we have some gap, and this is not about being pretty, it's just about being convenient. So hopefully this will give you a good view of what we're doing. Now there's a pretty good gap in here, it's about 1/16 to 1/8. What I'm going to do is I'm going to take our tool and I'm going to just try to melt it right up against our crack. And I'm going to try to smooth it and push it into the crack where it adheres to our staples. And it's kind of a slow process, but it really moves. It's not nearly as quick as a regular welder, but all you're basically doing is mixing and heating. And what I'm doing is actually pressing the plastic as it melts and smoothing it out into our groove. But I'm trying not to press too hard to create a bend. I'm letting it kind of do its own thing. I guess the more you do this, the better you're going to have a better feel of what you're doing. I'm just trying to meld it and press it in to the plastic. And I really don't care what the other side looks like as much as I want it to adhere. And you can feather in the top and the bottom as you go. And some of this is pretty thick, so I have a lot of plastic here, probably not as smooth of a strip. A lot of times people like to use strips that are looking like ties, and they'll fill in real good, but because I have so much thickness here, and it's hard to actually cut with the cutoff saw something really thin because that's a thicker piece of plastic, I figured this might be a good enough method to do what we're doing. It's not a fast process, it's kind of slow and tedious, but I think it does a pretty good job. And because we had all those staples in, like I said, I'm actually filling in the staples. Sometimes I think having a little bit more plastic, the better, because it's able to kind of melt itself and push itself in. But these are pretty good sized gaps, so I'm not feeling too bad. And this is the first time I've ever done this, so I think it's relatively very simple for anybody to do. Just have to take the time it takes to do it. And it's actually kind of fun. It's really not difficult at all. You know, you go around corners, you just kind of manipulate. It's kind of like holding a welder. But I'm actually filling in a pretty good gap. And like I said, knowing that there's staples in here, you know, you at least have something you can kind of push up against, and when they lock together, both the top and the bottom, I think that makes a difference. Now I'm in an area that's kind of a angle, and I'm going to try to get out of that angle here in a second, where I have a straight run, but I was actually kind of hitting a curve of the plastic. Like I say, I'm working with a very thick piece. Then I'm kind of moving around. I guess if I meld it completely off, it'd be fine, but I'm just trying to use that whole stick to get us to the end. And I'm not really too concerned about how much material I'm putting down because, as far as I'm concerned, it's just extra strength once it cools. I'm going to push this in here and kind of let it melt. The all-turn, the downfall, like I said, is the biggest beef I had with the all-turn is that thing would have shut off a long time ago just because it's constant heat. I'm working with a very thick piece of plastic, so melting's taking a while. It's probably too thick, actually. There he goes. Tell you though, working with a thick piece is really not that bad because it's really a good filler. You know, it's not like you're working on small levels, and then you can spread it out, feather things out. And you know, the one thing I like about the fact of what I'm using, it's definitely made from this company. So I'm figuring it would have, its properties to adhere are probably very good. Now, I wish I would have known about plastic welding a long time ago because, you know, it's kind of silly. There's a lot of opportunities out for you to fix a lot of things, and I've thrown a lot of things out I could have easily have fixed if I would have just kept this, had a welder like this, and found out how easy it actually is. And the staples, you know, if you didn't have staples, you'd have to use the mesh, and staples make it a little easier, and I think the combination of both these tools together really makes it shine. Like, it's well worth having both tools. That's why I didn't mind going out and buying another one, because they kind of like, they complement each other. And if you buy an alternate kit, I would definitely be looking at getting one of these types of welding with the feet, because it definitely allows you to move material, smooth material out. I think it does a better job than the all-turn. But I mean, I'm covering over a 6 to 8 inch, almost 9 inch piece, and I'm really putting down a lot of plastic. And once it cools, I think it's going to really do a nice job. And then basically I have so much material in here right now, I'm going to just move it around up to the edge. You know, when you try to melt, because I am covering staples right now, I kind of like the fact of having a lot more material. But there you have it. That's basically a rough idea of melting plastic. And I went through a lot, but I think it makes a big difference. And that's a pretty good base. And then once it's solid in there, I think it'll hold pretty well. And so I'm going to kind of continue on over here, but that gives you a good foundation of how this kind of works. And I mean, I could heat it and smooth it out a little bit better, and that's probably what I'm going to do. But it gives you a good foundation of what we're doing. And I'm going to do it throughout the whole thing. So it's going to take a little bit of time, but it's well worthwhile, I think, because that's going to give extra support to the staples. It's bonding to the two, and it'll hold a lot better. So it makes a big difference. So because I'm really looking for strength on this project, you know, it's not just that you put staples in and you put your plastic over the top of that. I'm going to show you, I also incorporated steel wool into the project. And what steel wool did once I blended it in to the plastic that we just put down to cover the cracks, it really worked like a fiberglass and really tightened everything up. And I think it made a hell of a difference. So I'm going to show you the difference between the one side that I actually did this and the other side that I didn't. I also put in a screen, and I put it in the two corners at the bottom and one here at this edge, because those are the two breaking points. Because normally it's going to crack into the bottom or the top, and it's going to travel throughout the piece. So I wanted to make sure that the corners of both the bottom and the top are super tight. So I'm going to show you how we incorporate the screen as well as how we incorporate the fiberglass. And I want you to take a really good look at both sides, because it's amazing when you put the steel wool in, how it looks like a fiberglass thing, and it just really increases the strength. It also smooths out so much better that I think it's going to hold a lot better, and it's really melted into the piece. So this side that I'm showing you right now has only the staples, and we put plastic in to fill the gap. There's no steel wool on it, and there's no screens. But we're going to put a screen here in the hole. We're going to put a screen here. And as we go down to the bottom, we're going to put a screen down here as well. And also we're going to put in more fiberglass. Or not fiberglass, but steel wool throughout the whole piece, like I said. And that'll tie everything together. Now when you look over here on the other side, I did the steel wool and the screen. In the corner here, there's a screen. And you can see how well it all blended in together. It seemed like it melded better to the plastic. And it's a lot tighter of a job. And it goes all the way down. And down here, I also put a screen right here too. So it's going to, I think it's going to hold a lot better, and it's going to hold very well. Not only are we going to do the steel wool and on the outside like I've just done, but I'm also going into the inside and do the same thing. Because the horses beat the hell out of these things, and they're very hard on these hay huts, I'm just going to do everything I can to make sure this is very strong and not to have any cracks. So, but I'll show you right now how we actually put the screens in. So to put the screen in is really simple. The first thing you need to do is just basically soften the plastic that you are. So I'm just going to take my tool and I'm just going to melt a lot of the plastic that we already put in there and smooth it out a little bit. And all I want to do is get that a little bit wet to adhere to what I'm going to put down. Then I'm going to take my screen, set my screen into position, and then start to basically melt the plastic into my screen. And all I'm trying to do is get that plastic to get wet and start to come up through the actual screen itself. And once it starts to harden, it'll actually adhere a little bit better. And I'm not actually putting material over it right now, but what I'm trying to do is melt the surrounding plastic to come up through the screen and adhere. And this is going to produce us a little bit more strength to our piece. And what's nice about these little welders, you really don't get so hot that you can't really overdo it. You're not going to like sink your tool through the plastic. At least this piece that I'm working with is at least 1/8 of an inch thick. It's pretty thick. So to melt through it is pretty hard, but it slowly heats up. And I guess sometimes you get aggravated, you want to move a little quicker. But, you know, if you go slow and steady, it gets the job done. And that's all that matters. You know, like I said, this is only $14.99 from Harbor Freight. So, you know, I can't expect for too much product, but it does a really nice job for the money. And if you're doing a smaller project, honestly, I don't think you really shouldn't complain about this, because you'll get your money right back by repairs. You know, the project I'm actually doing on this is a very large project, and I could probably need a more efficient system, but you know, for starting off, I think it does a really good job. And I could see that if you're going to use different pieces, I would definitely look at getting some stainless steel meshing for this type of project, and I think it'll make a big difference for you. So I'm going to let that sit for a second. But that's actually how we put the screen on. Just blend it in as we go. And I'm going to eventually, once this thing sits, I'm going to come back and melt plastic over top of this, and then also apply more steel wool, and that will finish this actual section. But I want to show you next, real quickly, right next to this, how we apply the steel wool. So I'm going to continue on going across the piece over here, and I'm going to show you where we're going to start adding steel wool. So I'm going to do the same thing. I'm going to go in here and soften up the plastic that I put in. And the reason for that is the steel wool, we're just going to kind of stick it and run it across our piece. And since we did put a seam in here, we just want to blend it together. Now you don't want to put tons of steel wool in. Like, here's a steel wool piece. I'm just going to try to spread it out a little bit and kind of work with it. So here's a nice chunk of steel wool. So I'm going to lay it in here, and all I'm going to do is hold it down and press it against the wet plastic. And that fiberglass is going to melt right into the plastic piece, and it's going to provide a strength that we're looking for. And we just keep feeding in steel wool as we go. And all you're going to do is hold your piece down as it melts it into the piece. And after a while, you can actually start to smooth it in position. And I do think by doing this, it is amazing how much strength it adds. Because if you even look at the steel wool, just trying to put your finger through it, it's a lot harder. But when you actually mix it in with the plastic, I think you're creating a better bond than just solely putting in plastic into the cracks, and it just creates more strength. So the way I look at it is this way. The hot staples are a great tool when it comes down to just getting your pieces to fit together. But they're not going to create the strength that you're looking for. And if you just put pure plastic down over the staples, it's still pretty brittle. But by adding into the mesh, the steel mesh, stainless steel mesh, and or applying the steel wool, you're increasing your strength dramatically in what you're doing. And what I also noticed too is just by adding this steel wool in, by trying to meld it together, it seems like it looks smoother, and it looks like it's a better adhesion between the plastic I added and the steel wool. It just makes a nice melded buffer where it's stronger. So now we're going to continue on with our steel wool. I'm just going to heat this section up right here. Then grab yourself some steel wool. You kind of pull it out to the amount you want. Now I'm using like a finer steel wool. And the finer the better, I think, because it's easier for it to be melded into plastic. If you get real coarse steel wool, and this stuff is extra fine. I bought it actually at Harbor Freight. It was like $2 a package. It was really cheap. And I bought like 3 packages of it because I have such a big project. And when I first started using this, I was surprised how actually easy it is to actually work with. And I think the finer it is, the better off it is because it blends really well into the plastic. And you could stretch it out as you want. And you don't need a lot of steel wool. I'm just kind of applying it with no rhyme or reason to it. I'm just making sure it kind of blends into the plastic. And the other thing too is once this is hot, you can go really gently across your heated area, and it works, it blends in real well. I think it's easier to work with the plastic once the steel wool is embedded in it than it is if you're just working with regular plastic. It's not a fast process, but I think it's a more thorough process. Now, if I wasn't worried about horses and beating on this, I wouldn't probably have to put as much effort into what I'm doing. But I think that if you're looking for something that's going to last a while and provide strength, the steel wool by itself is a great mixture. So that gives you an idea how it works. And I don't want to kind of bore you watching me do this for a long period of time. But it is a little tedious. What the tool do its work. Just all you're doing is pressing it in. And then after a while you can kind of work with it. It's kind of spread it around gently. But if you notice the way we started to where we're at now, the whole project looks a lot cleaner and a lot smoother just by adding the steel wool. And I'm sure the strength that I've added to it is going to greatly make a difference. So next I'm going to do is I'm going to get myself a piece and put more screen in here. And then I'm going to actually take some plastic and melt it on the screen so I can then apply steel wool and cover this section and work my way down with just steel wool. So I'm not going to bore you guys with watching me do that. I'm also going to go over here and add plastic to that and steel wool on top of that as well. That'll finish that whole section. Then if there's a section that's here that needs to be a little heated, a little more smoothed out, I'll do that too. But that'll finish this whole piece on the exterior, and then I'm going to move on the inside, and I'll kind of briefly show you what I'm going to do with that. And then this whole section should be complete. So the screen's in, and all I'm doing is taking my plastic, and I'm just going to lay it and heat it and let it melt over top of the screen. And by doing this, all I'm trying to do is coat the screen with plastic, so then when I put my steel wool over the top of it, I'll heat it and just smooth everything out. But right now my plan is just to kind of coat that and cover up the plastic itself with the screen. So the plastic is going to get covering up the screen, which allows me to adhere to steel wool. I've been going through a lot of plastic pieces, you know, that's got incorporated back into this project. And I just didn't smooth out what I currently exist. I actually added. And I think it's not hurting at all. So this piece here, once it's blended, and this is the exact same plastic, like I said, that this piece has been made out of. So it should adhere pretty well, because it's exactly like plastic. So I pretty much have this thing coated for the most part with plastic. And I think that I can probably, to the point where I can almost put steel wool in, and it should smooth out. And if I need to add a little bit more, I can always add more plastic. So let's put a little steel wool over there real quick, and that'll kind of end that section. So here's a bunch of steel wool. Just going to set it in there, and I'm just going to press down and let it melt. I'm such a believer in the steel wool right now, just by seeing how it applies and how it really makes a difference with the plastic, that I don't think I would actually do any project without using the steel wool. I think the steel wool really binds the plastic together, and it really provides strength to any project that you're working on. So even if I was filling a hole in a bucket, I would use a screen, and I'd probably use the steel wool because I think it does a nice job, especially on a thinner project that you have thinner plastic. It works out good. And on this kind of heater, because it's not a very one that you can overheat, I think they get about 500 degrees. It's not going to do a lot of damage to even thinner plastic, you're not going to like really fall through it. I think that makes a big difference. So this thing, steel wool, is pretty much melded in. And I'm just using my tool to just smooth everything out. And even if there's a little steel wool that you feel, I don't think it really is going to do any damage to it, because you do have everything kind of sealed. But once it's really embedded in with the plastic, I think it really is a binder. I think it will bind really well. It's also nice too is, even if you go farther out, because my crack was little, and even though I put a screen in here, you know, for it to sprawl out to the sides, you're actually covering a larger area. You're going to get more bonding. So there you go. You probably would never know I even had a screen in there. So pretty happy with that. So there you guys have it, all done, all the way down the side. And it has the screens, 3 screens put on. It's all secured in by the steel wool. And now all we have to do is the inside. And then this big piece will be on and be secure. Hey guys, I'm going to end the video here. I think you got the good idea of what it took to work on this project. I think I'm putting on the final touches and trying to finish a few things on the inside. But the whole exterior is done. Everything has screens on the bottom. They all have the steel wool going through it. My Chicago Electric flat iron died, so I want to buy a June Jip flat iron. And June Jip is a family-owned company. I really think this is a better product than the Harbor Freight. And you can get replacement tips. You can get all kinds of products right from June Jip. And retail price for this is like $60 for a really nice kit. You can buy one for $40, but I would go with the $60 and buy their deluxe kit. And June Jip basically will sell you basically any part of this you need. So I think, and they come with different tip designs as well. So you're going to buy a better flat iron, and you're going to have more adaptability with it than you would with the one from Harbor Freight. And look into my video on the June Jip versus Harbor Freight when we talk about flat irons, and you'll get an idea what I'm talking about. But anyway, this project really turned out pretty good. I'm pretty happy with it. And if you're a hay hut owner, at least you got a taste of what it may take to fix your unit if you own one of these, if you get any cracks. My mistake is I let this thing get beat up way too long. It took a long time to do, and I probably would get a hot air welder in the future versus this, because it took me a long time to fill in the cracks. If I could have filled in the cracks faster, I would have been done a lot quicker. Even if I would have put in and used different tools to do my welding with, and you know, I think it would have went a little quicker. But you know, to keep it on a budget, I think that what I bought was perfect. And for most of the things that most people would use a plastic welder for, you know, this is an excessive project. And I have other larger scale projects that I want to use these types of tools for, and I'm kind of excited to see what happens. So with that said, hey, thanks for watching. Hopefully you guys learned something from this, and at least you could see what it's like to work on a real large project versus just fixing a boat or fixing a pail, you know, because there's so many things you can fix with these plastic welders, and they're so cheap, anybody can learn, and they're very simple to figure out. So with that said, thanks for watching, guys. I'll talk to you guys soon.